Good morning, everybody. Welcome to Tibbetts Physics. What is crappin'? I'm your teacher, Mr. Tibbetts. Today we're going to talk about three things: the metric system, scientific notation, and order of magnitude, or if you like Harry Potter, we call it the order of Phoenix. Before we get started, I got a question for you, and that's, what is your body's temperature? Most of us will say 98.6. Maybe if we're lucky, we'll say 98.6 degrees. But really, it's important to include the units, 98.6 degrees Fahrenheit. Now, why is it 98.6 degrees Fahrenheit? Who figured that out? Well, we have to understand that our temperature is based on a scale, and it so happens to be, by some weird coincidence, or not even a coincidence, it's just 98.6 degrees Fahrenheit, but it so happens to be that at that temperature is when our body is in homeostasis. But the important thing, again, is units. So the first thing we're going to talk about, or look at, is the International System of Units. Or the SI units, System International. This is also known as the metric system. Now, it says international. That means every single country in the entire world uses these units. Well, let's see if that's true. So here we've got a map, and it shows us all the countries that use the International System of Units. Well, let's look at the ones that don't. We've got the United States, the most powerful country in the world, including Alaska and Hawaii over there. And then we've got a country over here in Africa, Liberia. Probably the second most powerful country in the world, would be my guess. And then we have one over here right next to India called Myanmar. And I would assume that's the third most powerful country. So these, again, for some reason, are the countries not using the metric system. Let's look at the countries that have put men on the moon. The most powerful country. So I'm going to assume that these two are the next to put the men on the moon. Okay. Anyways, so in physics class, we use the metric system. And it goes by the powers of 10. It turns out that in the 1700s, when all the world, aka Europe, was trying to calculate the circumference of Earth, a guy came along and said, geez, it'd be much easier if we go by the powers of 10. So we have 10, 100, 1,000, and so on. And we can also go backwards to the decimal places. Tenths, hundredths, thousandths, and 10,000ths. Okay, so that's how scientists are somewhat lazy, as we go by the powers of 10, and it makes our lives pretty easy. But scientists like to be even lazier, so the next thing they came up with are prefixes. And this time these are words that represent powers of 10. So it also is powers of 10. And these go in front of your units. Fortunately for us, on the bottom front page of our reference table, in the bottom left corner, we've got a box of prefixes. So let's look at that. So these are the most common prefixes, powers of 10, that we're going to use in our physics class. These go with any unit. So it could go with meters, grams, newtons. So let's look at I'm going to look at one that's pretty common, that's meters. So I'm just going to assume that all of these down here are just going to represent meters for the time being. So let's see here. Let's look at what a meter is. Well, we don't see it here anywhere. 1 meter, notice that we have all these powers of 10s, is equal to 10 to the 0 meters. If you remember 0, 10 to the 0, it's not 0. 10 to the 0 is 1. So 1 meter is really just 1 meter. So that 10 to the 0 should go right in between the 10 to the 3 and the 10 to the negative 1. So let's look at a prefix on here. We've got centi. Let's look at 1 centimeter. and we go all the way over, and that's equal to 1 times 10 to the negative 2 meters. Let's look at kilo. So we got 1 kilo, 1 kilo or 1 kilometer is equal to, we go all the way over, 10 to the 3, 1 times 10 to the 3 meters. What would 1 tera be? Why don't you try that on your own? 1 tera. Alright, good. Hopefully you just went all the way over and you saw 10 to the 12th, so 1 terameter is equal to 1 times 10 to the 12th meters. So that's powers of 10. That's how us scientists are lazy. We're going to look at scientific notation in a few minutes. So really quick, since we're talking about units, let's talk about units of measurement. Let's look at some common ones that we use early on in physics. First thing we'll look at is length. Length measures distance and displacement. This is probably a new word for you, and we'll learn it in probably a couple of weeks or even a couple of days. Okay, so we measure length. We use the tool as a meter stick. And the units of length are meters, or M for short. Okay, next one is mass. Mass measures your inertia. Another new word, but we can also call it matter. To measure mass, we just use a scale. And its units, these actually have a prefix in front of them. Its units are kilograms, or kg. Sorry for my sloppy handwriting. The waitress gave me caffeinated coffee when I specifically asked for decaf, and my hands are a bit shaky. Okay, next up is time. It's getting pretty late right now. It's past my bedtime, actually. Okay, now time is hard for me to define, so I think we could skip that part. It's pretty self-explanatory until we get into space-time, but for now we're just going to look at time as it goes forward, and just look at a clock for that. So time, well, we use a stopwatch to measure it, or a photo gate, or even your iPod. And its units are seconds. Oftentimes you'll find units in minutes, and just be sure to convert it back to seconds. Okay, 2 more. The next one is force. Oops. Sorry about that. Force. Force measures our weight, different from mass, and it's also a push or a pull. To measure force, we use a spring scale. That's kind of like the thing that you find in grocery stores when you're measuring your fruits and vegetables and you want to figure out how much you have to pay. Spring scale. And its units are newtons. That's a capital N. Named after Isaac Newton. Okay, last one is temperature. We talked about that at the beginning. What exactly does temperature measure? Well, temperature measures energy. It's how fast or slow particles are moving. To measure temperature, we use a thermometer. And its units in physics class, we're going to go with degrees Celsius. Hopefully I can spell this right. Degrees Celsius. Okay. I think that's spelled correctly. All right. Welcome back, everybody. We're going to finish up our first lesson that includes scientific notation and order of magnitude. So let's look at scientific notation first. So all that is some numbers with a decimal in between them. So let's look at 1.93. And then we have times 10. So we're going by powers of 10 again, still a scientist being lazy. And it's raised to some number. So when you have a number times 10 raised to a number, that's scientific notation. Now, if you want to write this in your calculator, you want to use your EE button. It's very handy when you're dividing by powers of 10. So if you typed in your calculator, it looked like 1.93 EE, that's second EE in your calculator, and then just 11. And that will read it as 1.93 times 10 to the 11th. Alright, so let's do some conversions. We'll look at the distance to Andromeda Galaxy. This is the closest galaxy to our Milky Way galaxy. Oops, Andromeda. And it's actually on a collision course with our galaxy. One of the very few galaxies that are actually heading towards each other. So, how far away is it from us? Well, it's 2, 4, and a whole bunch of zeros. If I were you, I'd count along. Oops. And meters. Okay, so obviously we don't want to write this every single time, so we're going to put it in scientific notation. So what we do is we want to count how many placeholders there are, starting here, our last number, all the way in between our first two numbers. We're just going to count along how many times we have to move over through each zero. So let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 times. So our decimal ends right here. Our final answer is 2.40 times 10 to the 22, because we moved over 22 times, meters. And we'll box this. Quick tidbit. In the future, we'll do sample problems on a separate video. This way you could look them up easily rather than having to watch through the entire lecture notes. Thanks. Okay, let's do one more. This time we'll do the opposite direction. Actually, why don't you try this? We'll do it together. We'll look at the mass of a proton. Mass of proton. This time it's actually a really small number. We've got 0, point, a whole bunch of zeros. I would count these if I were you. And then, a couple of numbers. Kilograms. Long number, but really small number. So now we're going to do the opposite. We're going to start at the decimal, and we're still going to count in between the last non-zero number and the one after it. So that'd be up to right here, the 1 and the 6. So let's do some counting together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Jeez. 19, 20, 21, 22, 23, 24, 25, 26, 27 times. So we got 1.67 for the mass of the proton times 10 This time we move to the right, and it's going to be a smaller number, so it's going to be raised to a negative power, so 10 to the negative 27 kilograms. Okay, so the last thing is, and this is really quick, the last way of physicists being lazy, and that's the order of magnitude. And this is when we're comparing numbers that are similar in powers of 10, but not necessarily the numbers before it. So all we do is the order of magnitude. Let's say we have 1.35 times 10 to the 22 meters. The order of magnitude is just the power of 10. The exponent above the 10. Above the power of 10. Okay, so the order of magnitude of this number, 1.35 times 10 to the 22, is 22. Order of magnitude is 22. Let's look at this one. Mass of the proton. What's the order of magnitude of this? Power, the number above the power of 10 is negative 27. So the order of magnitude, negative 27. And the distance to Andromeda Galaxy. Why don't you try that one on your own? Hopefully you got 22. Very good. All right, and that's it for today with me. Have a good night.